Good morning, everyone. I love it. All right, so this is going to be really a timely session because we are about to have lunch. So after this session, I'm hoping that you're going to be hungry and having a really good lunch. So today we're going to talk about Python and serverless. If we can switch this slide, yes. So the original title is From Dev to Deploy, how to build serverless applications with Python on AWS. And my name is Donnie Prakoso. I'm a principal developer advocate. I have a couple of social media where I post anything about AWS and also the latest edge of the serverless and containers. I'm specialized in DevOps and microservices. So if you want to have a chat, if you have any questions that you can ask me during these sessions, please reach out to me after this session, or you can also ask me on LinkedIn. Now, so the idea of this session is actually pretty simple. You know that I'm working for AWS, right? But I want you to hear from me, as I am a programmer who've been building Python since the version is 2.2.3, since Python 2. So if you track back when it was released, I think you will know roughly how old am I. So yeah, it was a long time ago. I started in banking. Most of my career is in enterprise. I started in banking. I built this loan originating system with Python, building this SMS gateway from SOA with Python as well, and startups as well. So I survived migration of Python 2 to Python 3. That was the most enjoyable moment for me and my team back then. I've deployed many Python applications into bare metal, VM, containers, and serverless. And the key takeaways for you for this year is that to understand my perspective, why developing your applications with Python on serverless is amazing. Because it really changed our perspective. Because before serverless, before the cloud computing, we always think about the traditional approach on building applications. That could be a monolith. We put everything into one single place and we run it, right? So, but developing with serverless, it actually needs a different set of perspective. And I want you to understand as well, after this session, that you understand how to develop a serverless application in Python and use modern tools to deliver more with less efforts. So that would be my key takeaways. I only have a couple 35 minutes for this, so I'm going to jump straight into demo. So if you can, scan the QR code. Yeah, so this is actually one of my favorite food. Yeah, so my favorite food is actually silog, right? So I went here on Thursday. I already had 3 silog, beef tapsilog for the past 3 days. So this is it. This is a simple voting applications. Oh, you love sisig? Okay, a lot of people. Oh, wow. Okay, that's really cool. Now, what I want to show it to you is actually pretty simple. This application is built with this architecture. Everything is running on serverless with Python. I use Amazon API Gateway. I use AWS Lambda running Python 3, and then I use Amazon DynamoDB. And it could scale no matter what. Like for example, you just like there were like a 200 votes for sisig. It could scale almost indefinitely. So we don't need to think about that later on, so we can focus on how that we could build a better application. Now, any one of you here already using serverless? Raise your hand. Okay, some of you. Now, something that I would like criticize whenever we building applications is like this is the stage from dev to deploy. We need to explore and plan. We need to develop. We need to define the application environment, testing, and CI/CD, right? And then we also need to optimize and operate. But something that I really criticize is that our journey when developing applications is not going to be as linear as this. It's actually like we move things around. Sometimes we need to think about the feedback. We need to see all the logs, all the metrics, and then we need to go back to the step 0, which we need to explore and plan. So this talk is going to help you to understand how that we can run each of these stages with Python and the tools. There are two stars in this talk. The first one is AWS Lambda. Anyone knows about AWS Lambda? Raise your hand. Cool. Oh, a lot of you. Okay, so for those who haven't heard about AWS Lambda is one of the most amazing items that have been released in the era of cloud computing. Why? Because it was released 11 years ago, in 2014, late 2014. It was launched as event-driven function. It was ahead of its time, and it supports Python from its launch. Now, why I mentioned this is really cool, because the event. So the way it works is that Lambda is just a function that you could trigger. And then you can interact with your database or AWS services, or you can call upstream services. It doesn't really matter. It's just when you develop a functions, you can run it on AWS Lambda. Now, event is something that's really amazing, because event could be anything. Like, for example, you want to build an HTTP request. You build with Amazon API Gateway. This HTTP call is actually an event. If you want to upload your files into, like, for example, Amazon S3, this will trigger event. So events could be anything. The other key topics that I would like to share is that generative AI. Now, generative AI is, I experimented with generative AI last year for the full straight 8 months. Everything is on generative AI. I was a bit skeptic before, but I felt there was a really big difference with me developing Python with generative AI and my traditional approach. So this is something I would like to share with you as well. Okay, step 0, explore and plan. Now, for those of you who are kind of a bit new to serverless, some of the questions that I get is like, what is serverless? Is it no server? Or is it less server? Is it about cost? But it's more different. Serverless is actually an operational model. It's the way that we think. It's serverless and operational model in a way that if you see this diagram, these are the serverless offering from AWS. Like, you need compute, you can use AWS Lambda. Or you want to run a container, you can use AWS Fargate. Oh, wait, I need a database, I need RDBMS, but I don't want to manage the server. Oh, I can use Amazon Aurora Serverless. So serverless, it doesn't only apply to one specific layer, in this case computing, no. It's not only AWS Lambda, but it actually a lot of services that we can apply this operational model. Now, this is a quick overview of AWS Lambda. So this is more like the elaborated version of the previous slide that I present to you. So the request, I can talk you through from left to right. From the left side, we have all the events. It can go from specific services, or you can create on your own. And then we have a code, we have a config, and then you can also create a version and alias. Now, one thing that I really like about building application with AWS Lambda is that because it's really in a granular way, you can be more flexible on building your architecture. It doesn't really dictate if you want to have one function per functionality, which we call as micro function, or if you want to run a big monolith and put it into AWS Lambda, which we call it as Lambda list. So most of the developers think about, oh, I want to use Lambda, but I need to use microservices. No. It doesn't really dictate on how you define your architecture. It's more on how you think which part of the business that you want to delegate or run as serverless. Okay, so the next step is actually develop. If you haven't tried AWS Lambda, this is how it looks like. We have, this is the Python language. We have a Lambda handler, and we have this import JSON. This is import library, and we also have to return. As you see, this is just a normal function. If you want to get started with AWS, not only on AWS Lambda, you just need to import this library, which is Boto3. Right? So it's Boto3. Now, the next thing that I want to share with you is something that I use really frequent, and that is Lambda layers. Now, Lambda layers is something that if you think about, if you need a shared library, if you're developing with teams, and all of you have one shared libraries that all of you use together, you can use it as Lambda layers. It's going to help you a lot because it also reduces the cold start or the execution time of your AWS Lambda. Now, I want to show you this one. So this is how it looks like. This is AWS Lambda. And you can see this is just a simple AWS Lambda. You can go to the source, you can go to the console, or you can use your IDE, which I'm going to talk about that later on. And this is one example of what I built as a monolith approach of AWS Lambda. You can see on this part is that I'm using Flask model, which I'm going to talk about that because I want to clear the misconception that you cannot use our favorite framework, either that Flask, Django, or even Fast API with AWS Lambda. You can. I'm going to show you more about that later on. But yeah, and then this is actually the Boto3. If you want to interact with any of AWS services, this is the library that you need. Now, sometimes it's really hard for you to start from scratch. Sometimes if you're just getting started, hey, how can I build something with DynamoDB? Okay, so something that I want to show it to you. Okay, so I'm going to create just app.py. So this is where you can use generative AI. Like for example, is it too? Okay. Like if I want to create create a function to save data into DynamoDB. That's it. I'm using Amazon Q, Amazon Q developer. So the idea is that we need to minimize the friction if we want to get started easily. And that's why I use generative AI. Now, it's really useful if you want to just get started. But there are other tools that I want to show it to you. And this tool is really amazing because it helps me to build application with best practices. Now, and that is Power Tools. So if you just building this application with AWS Lambda and you want to implement observability, like including the logs, metrics, or traces, or you want to build idempotent application, how can you do that? Yes, you can build from scratch, but the better way to do it is just include the library. And that library is called Power Tools. Now, for example, you can just use these Power Tools to implement tracing. You just need to add some of them using decorator like this, and it's going to integrate easily with your AWS accounts, which is in this case is X-Ray. Yeah. So if you want to understand how to develop with best practices, there are two advice that I can give it to you. Try Amazon Q Developer, which is free. There are two tiers, but I'm using the free one, and use the Power Tools. Okay, so the next one that I want to show to you is, where am I? Okay. Oh, this one. Power Editors. So I mentioned to you that you can actually use your favorite frameworks whenever you build application on AWS Lambda. Now, I got this question a lot. For those developers who already invested their applications, if they're using Flask or using Django or using Fast API, how can I run my application on AWS Lambda? So the answer is you can do that by using AWS Lambda Web Adapter. So AWS Lambda Web Adapter is going to wrap your applications if you're using like a Flask or Fast API, and then you can just run the applications on AWS Lambda. Like for example, I have one, not this one. Okay, so I have this one content summarizer and image generator, which is using Amazon Bedrock to summarize an URL for me. And it's going to generate a feature image. In this case, is this image. And the beautiful thing about this application is simply that I'm building this using Flask API. Is it Flask or Fast API? So let me check. Oh, not in this. So this one. Yeah, so this. So I built everything on Flask, and then I deployed with AWS Lambda. And it's really a good way if you ask me, so what is the better approach if I want to run AWS Lambda? The better approach is just use a vanilla Lambda functions, which is in this case just a handler. But if in this case that you already invested your applications using a specific framework, yes, you can use Lambda Web Adapter. So that about developing. The next step that most developers usually do, and I really advise this one, is defining infrastructure and architecture with Python. So, and in the past few years, I've seen a breakthrough, especially on the DevOps, because in the past we have development team and we also have the operations team. But now we have this new paradigm on bringing all together, which is to combine dev and ops. But what I've seen is that there's a new shift that is actually breaking down the barriers between dev and ops, meaning that you can have your team building applications and also building the infrastructure and architecture at the same time using the same language, which is Python. And that tool is actually called CDK. AWS CDK is short for Cloud Development Kit. So it's a tool that is open source tools that you can use to define your architecture and infrastructure using your preferred programming language. In this case, in my case, is Python. And so this means in your one single repo, you can have your application and you can also have your infrastructure running at the same time, and you can integrate them as part of CI/CD. Now, the next thing that I want to mention to you is about how that we think about our application environment. In the past, whenever we build an application, everything can run in one single machine. Yes, that's why the testing, the staging, sometimes it's in one single machine and it works just fine. But when we deploy on another environments, it just didn't work. Now, the modern applications, in this case is serverless, we introduce a new perspective. And this is actually the 12-factor apps. Anyone knows about 12-factor apps? Cool. So 12-factor apps is like a guiding principles developed by Heroku. It's around 12 years ago, if I can remember correctly. And in one of those guiding principles, there's dev and production parity. In a nutshell, it means that if you have different application environments, make sure they are as similar as possible. Why? Because you need to reproduce the errors or the features in one environment into other environment. Now, what makes it different is that you don't need to build different application. You only need to have one built artifact, and what will differentiate is actually just the configuration. So for example, you have 3 application environment, dev, staging, and production. You have 3 environment, but only 1 application. Okay. Now, I just want to share to you on how that you can run CDK. Okay, so this is my CDK. As you can see, I'm importing this AWS CDK library, And this is the DynamoDB table that I use. So I'm using a DynamoDB. This is the architecture that I use for the 14 apps that I showed to you in the first demo. And this is Lambda role. And then this is the Lambda function. Right? As you can see, everything is in Python. And this is the Amazon API Gateway, which is the REST API that I use. And this is the integration. Now, once that you finish this, what we can do is that we can just we can list down all these applications that are available. Oh, we have this one. Okay, so, and the next thing that I can do for this one is that I can just deploy this application. So in this case, I have the applications running on Lambda functions and also have the infrastructure and architecture. And this is the output. The output is a direct URL for my API. So in this case, if I just run my browser, and there it is. This is an API. So this is really cool because it breaks down the barrier between dev and ops. Now you can develop applications and build your infrastructure and architecture with the same programming language, which is Python. Right, so, okay, so the next thing that I want to show it to you is that we have talked about building the application on AWS Lambda, and we already talked about defining the infrastructure and architecture. The next best practice that I want to share with you is that you need to implement CI/CD. CI/CD is one of the key that you can improve the velocity. If you can minimize the feedback loop that you have, you will have this more opportunity to build more features and deliver for your customers, right? So this is a example of the CI/CD. This one I'm using, so there are three things in CI/CD, yeah? Continuous integration, continuous delivery, and continuous deployment. This one is continuous delivery, which in this case, if I commit and push code into my Git repository, it's going to trigger a build, and then using the CDK, and it's going to deploy it to staging, and then it's going to do testing again before it goes to production, but it will not deploy into production immediately. We need to manually approve it. So this is how it looks like. I have so many tabs here. Let me see if I have opened one of them. Oh, this one. Yep. So this is I'm using code pipeline in this case. We have source, we have build, we have update pipeline, we have assets, and we have staging. But it's not yet gone into production because it's waiting for approval. So in this case, I can just review this, approve. And then I can just submit the request, and it's going to deploy into the production. Now, the good thing about building with CDK is that you can use a library called CDK pipelines. So you don't need to start from scratch. You can just use a CDK pipelines to implement CI/CD on AWS. And I have a few examples. If you're interested, I can show it to you after this session. Okay. So the next one that I want to talk about is about testing. Now, testing is something is going to be different because we used to do this unit test, integration testing, and E2E in one series of machines. But in the serverless perspective, you can do the unit testing on your local machine. You just need to test the business logic. But if you want to test the integration testing, this is similar to what I mentioned earlier. You need to test it on the cloud. Right? Why? Because we need to make sure that everything works properly, even in its different application environment. Now, if one of the good things, if you use Amazon Q Developer, is that you can also use /test to build a unit testing or integration testing for your application. And it works really good. This is one of the example. You can generate unit tests, and then you can need to select the workspace or even one single applications, and it's going to generate the test suite for you. Usually, it's going to use a Pydantic, or if you need to use a mockup, it's going to include the library, Python library called Moto as well. Now, okay, so the next one is that something that I really like, and that is that you need to review and fix your code. Sometimes we don't know if our code is written properly, and with Q developer, you can just use /review. So I'm going to show you a quick example on how that we can use this Q feature. You can just go into Q, chat, and then you can just run review. And it's going to add all the workspace that you open to review, and then it's going to help you to identify all these issues. Okay, so the next one that I want to share with you is the best practices. The first thing that I want to share with you is the event is the language of serverless. So when you're building with serverless, you need to think about event. Like in this case, I'm building an architecture called event-driven for an e-commerce application. So in this case, everything is running stateless. They don't know each other. They just run by a function. And then I do have some demo on this, but I think can we do better? I have 5 more minutes. I can do a fast demo for you. If you can scan the QR code again. Oops, sorry. Okay. So the QR code, and what I'm going to show to you is this one. So you just trigger a service, order service, and as you know, there's a fulfillment service which I simulate like it takes like 10 seconds, but everything is running properly. So this is what I meant by event-driven, that you also need to think about asynchronous way. Okay, so the next one that I want to share with you is the best practices. One of the biggest challenges when we introduce Lambda is called cold start, which is the execution needed to load the Lambda. And you can actually optimize the start times by going to logs inside. So here you have this full report on which part of your Lambda function that needs to be optimized. And to find the best memory configurations, you can also use power tuning. So power tuning is a AWS step functions which will identify you which one has the best cost or the best timing. So I just want to give a quick show to you how it looks like for the power tuning, because apparently I only have 3 more minutes. This is the result of power tuning against your Lambda functions. I understand what is the best cost if I need to use this memory, and the worst cost or the best timing or the worst time. It's really helpful because it helps you to maintain the pricing. All right, so couple of ending slide. I think that's all from me. Now, couple of the next, if you want to scan, if you want to get this PPT, I'm hoping that you can scan the QR code, and then I'm going to send you over emails for the PowerPoint presentation. Yep. So, and then this is the QR code for get this presentation. I'm going to send it to you in hopefully after I got back from Philippines to Singapore. But yeah, if you already give me your feedback and also your email, I will send it to you. All right, so thank you everyone. Hopefully this gives you more insights on how we can develop serverless on Python and AWS.